Hi everyone, welcome to your first lesson of electric circuits, which is our last unit in grade 12 physics. So just a reminder that I'm on the Google Meet on Google Classroom from 8:45 to 9:45 if you have any questions or you just want to say hi. To start, please read these pages from the book to introduce the topic. Hopefully you had time to do the reading, and now let's talk about the information. We'll start with some definitions. Hopefully the first two look familiar to you. Conductor and insulator are a way to classify materials depending on their ability to allow charges to flow. A conductor is a material, usually a metal, that allows electric charges to flow easily, where an insulator is a material that does not allow electric charges to flow easily. And now we have a voltaic cell, and that's a cell consisting of two different metals called electrodes placed in an electrolytic solution that produces an electric charge on the electrodes, and that converts chemical energy into electric energy. So Volta invented the voltaic cell in the 1800s when he placed a salt water soaked paper plate between discs of two different metals. He discovered an electric charge on both of the metal discs. If you look at the diagram on the left, this is a voltaic cell. The two discs are called electrodes, and the solution between them is called electrolyte. Then over here is a stack of discs, which is called a voltaic pile, or more commonly called a battery. You can see that is just a voltaic cell repeatedly on top of another. The two ends of the pile have different names. The top is called the anode, which is positive. The anode is where the electricity moves into, and the bottom is called the cathode and is negative. The cathode is where the electricity flows out of. Then there is electric potential difference. The electric potential difference between any 2 points is the change in potential energy per unit of charge between the 2 points. This is also known as voltage, and the formula to determine voltage is the change in electrical potential energy, delta EQ, divided by the quantity of charge, Q. So the change in potential energy is measured in joules, and the quantity of charge is measured in coulombs. So 1 joule per coulomb is called a volt, and that is what voltage is measured in, usually with a V. So the difference in this electric potential energy is what is known as voltage, and voltage can be thought of as the driving force which causes the current to flow. Current does not flow unless there's a potential difference, voltage, present. So we often see a 12-volt battery, and that's when it provides 12 joules of electrical potential energy to each coulomb of charge as it moves through the cell. Like 1 volt is a battery cell providing 1 joule of electrical potential energy to each coulomb of charge as it moves through the cell. So if you can do these 3 simple questions to check your understanding, the answers will be posted in the classroom. The last topic for today is electric current, the flow of electric charge. So current, I, is the amount of charge passing a given point in a given time. Measured in amperes, current flows from high electric potential to low electric potential. So current, I, is Q, the amount of charge in coulombs, divided by delta T, the time interval in seconds. So I is measured in amperes, so 1 ampere is equivalent to 1 coulomb per second. So with that information, you should be able to complete these questions. Just remember for number 11, you will need to remember power is work over time, and work is the change in energy. So if you have any questions, email me, or I'm on the Google Meet today from 8:45 to 9:45. Okay, bye.